All right, so what are we doing here? I have replaced the driver circuit board, which is this guy, on this, I think it's an 82 Monte Carlo V8 tachometer. You know, this is 40 years old. And it has been replaced with this from Cajun Tach, which is now all updated circuitry. What's really nice is that there is a rheostat right here that allows you to fine-tune and calibrate the tach. And my issue is that, first of all, this is very old, and God knows how accurate it is. But it's going into a V6 car, so it's going to read high no matter what, or is it low? It's going to read high because it's going to be reading low because it wants to see more signals per revolution than it should be getting. So my engine's actually revving higher than this says, and God only knows what that actually says. So this has been put onto here. This is my tachometer, and this is what makes everything work. This is a tachometer. This is a signal generator. It's actually a pulse width modulator, and you can set the hertz for. You can set the number of hertz that it outputs. So what this does is this has two lines, positive, negative, that go to a power supply. This power supply is set up to give me a constant voltage of 12 volts. There's a little bit of a current draw right now, and I'll show you why. Just leave that on. And if you look down here, this is it powered up. And this is what it says it's outputting. It's outputting 50 hertz at 50% of power that this thing is able to put out. It's a good place to be. So 50 hertz. How do we look at hertz? What does hertz mean to a tachometer? Well, I'm going to go to my spreadsheet instead because I should have it here. Okay, yes. I made a spreadsheet of what hertz to RPM means. So for a 4-stroke engine, the RPM signal in hertz is equal to hertz times 60 divided by the number of cylinders. So hertz. 1 hertz is just a generic number of reference. 1 hertz means 1 cycle per second. 1 cycle of whatever. So if you need RPM, that's revolutions per minute, so that's 60 seconds. So that's what the hertz times 60 equals. Because the distributor will give a signal for every single cylinder, you have to divide this number by the number of cylinders and then multiply it by 2 because your engine travels twice. A 4-stroke engine travels twice for every ignition revolution. Like to get back to top dead center on the compression stroke of cylinder 1, the engine's going to spin twice. First for the compression, combustion, and then the exhaust, then the intake, and then the compression. So that gets you, there's 4 cycles, but you're actually doing 2 full revolutions to get to where you're going to be firing again and have the tachometer read a full revolution. So, all right, let's see what happens. First off, the first check is that a tach that is not powered will have the needle start to float. Let me get a good angle on that. So the angles start to float. So when I turn the power on over here, we'll see the signal generator light up, and the tachometer moves to 0. If you're replacing a needle without any signal coming through, that's when you set your needle. So if this didn't have a needle on it, you would power it up with no signal wire attached and place your needle so that it is nice and zeroed. There it is. It's nice and zeroed. Okay, so let's go back to our chart here. So the signal generator is set at 50 hertz out. If we look at my chart, 50 hertz is going to equal, for 6 cylinders, 1000 RPM. So what we do, I'm going to turn this off first. I'm going to connect this up. Let's see. Okay. That is connected to the coil output or input. So now when I turn this on, we should get light, and we have 50 hertz output. We see 1000 RPM on the tachometer, and for a 6-cylinder engine, 50 equals 1000. So what? How to test this? We should set it for our red line, basically, and I really don't know what my red line is for this engine. I'm gonna pick, say, 5000, as 5000 is where I absolutely want the tachometer to be accurate. So if I look at my chart, 5000 is at 250. I could do 300. Let's do 5000. So when I set this signal to 250, let's see if I can get this all in the same frame. We should see the tachometer adjust. So let's go up and signal 33. There it is, 250. And I've already calibrated this, so that's like dead on at 5000. Well, it's a little low. That's a little low. So we can adjust that a little bit. Where's my little screwdriver? Ah, there you are. Okay, so can I do this with one hand? Let's see. So we're gonna, there's a screw here. There's a little rheostat here. Come on. And it. That's it. Okay. So now we can rest assured that when this is seeing that number hertz, it's going to be reading that. So let's do a test, and let's pick something else from the spreadsheet. Come on, I need more fingers. There we go. So let's do 75, which is 1500. So when we set this down, 67, 2, 3, 4, 5. That is dead nuts on at 1500. So one more test. Let's do 3000. 3000 is 150. Let's go up. No, too far. Come on, down. 5, 4, 3, 2, 1, 0. 3000 RPM. There you have it. I am actually going to do this for the Chevelle as well. They make a replacement for the Chevelle. This is what the Chevelle circuit board looks like. I'll get around to that soon. But Today we're doing the El Camino, and we're putting in LED dash bulbs. Let's see if we have those over here. Make the camera work. I'm updating all of my dash bulbs to these. Come on, focus. There we go. I like these because they are actually labeled positive and negative. There's no first guessing and then marking with, you know, on the bench. And these are super bright, warm white with 5 LEDs. There's the big center one and then 4 around the perimeter. So good stuff. Enjoy. I'll show you a picture when I get the dash back in and all lit up. So till then.